This is a continuation of my lecture on trigonometric integrals. And this morning I'm going to talk about integrals of the form integral of tangent to the m of x secant to the n of x dx. We will consider two cases for this form. The first case is the case when n is even. That means when the exponent of secant is even, regardless of whether m is odd or even. Okay. And the second case is when m, which is the exponent of tangent, is odd. Okay, so let's consider examples to illustrate these cases. Let's start with say integral of tangent to the 6x secant to the 4th x dx. So it falls on the first case because our n is even. Okay, the exponent of secant is even. Now, how do we evaluate this integral? One of the trigonometric identity which will be useful in this case is the identity given by secant squared x equal to 1 plus tangent squared x. Now, what we will do here is to express one of this as our u, and then we will separate our du. Okay, of course, the obvious u here is tangent x, because the derivative of tangent x, if you recall, is secant squared x, which you can easily obtain from this expression. So that's the reason why we restrict this to be even, so we can easily separate the du, and the remaining factor secant squared x can be converted into tangent by using this identity, right? So let's do that. So what we're going to do first is to separate a factor from secant to the 4th x. So we have secant squared x times secant squared x dx. So that means that we will reserve this for our du. And if it is your du, then your u must be tangent. So you have to convert this one to tangent. So we have tangent to the 6x. But secant squared x is, according to the identity, is 1 plus tangent squared x. So we replace that with 1 plus tangent squared x. We have secant squared x dx. And let's perform multiplication. So actually we can write this as tangent to the 6x, and then secant squared x dx plus the integral of tangent to the 8x, then secant squared x dx. Integral of the sum is the sum of the integrals. Okay, so we can now perform the integral here, because as you can see, your tangent is your u, so this is u to the 6. That means that this is your du. Here you have u to the 8, which means that this is your du. So the integral of this u to the 6 du is 1 over 7 u to the 7, right? Or tangent to the 7th x, okay, then plus the integral of u to the 8, which is 1 over 9 u to the 9th, or tangent to the 9th of x, then plus c. So we have the integral of the tangent to the 6x secant to the 4th x dx. Okay, so that's for our first example. Let's move to the next example. This time, we're going to consider the case where the exponent of tangent is an odd number. Let's see. Maybe we can use the expression integral of tangent cube x secant to the 5th x dx. For this particular case, what's important is the exponent of your tangent is odd. So it doesn't matter whether the exponent of your secant is odd or even. But if the exponent of your secant is even, then you can use case number 1. Okay. So what to do for this particular case? Okay. When the exponent of your tangent is odd, then we will use secant as our u. But if your u is secant, the derivative of that, which is du, is secant x tangent x. So that means that we will separate from this expression our du, which is secant x tangent x, which we can easily obtain from tangent and secant. Okay, so if we separate a factor from tangent and secant, then we have secant x tangent x, which is our du. So that means that we'll be left here with tangent squared x, while this one will be left with secant to the 4th x, and then your du, which is secant x tangent x dx. Okay, remember we obtained that from tangent cube and secant to the 5th. Okay, so if this is your du, your u is secant, right? Because the derivative of secant is secant x tangent x. That means that we have to convert tangent squared x as secant using the identity again. If you remember that identity, okay, this one. So we express tangent as, okay, manipulating this, we have secant squared x minus 1 times secant to the 4th x times our du, which is secant x tangent x dx, and multiplying this, we obtain integral of secant squared and secant to the 4th is secant to the 6x times secant x tangent x dx minus 1 times this. Okay, so we have secant to the 4th x times secant x tangent x dx. Okay, again, your u is secant, so this is u to the 6, and the derivative of secant is secant x tangent x dx, so this is your du. This is u to the 4th, and this is your du. Okay, and evaluating now the integral, we have 1 over 7 u to the 7th, or secant to the 7th x minus 1 over 5, okay, then second to the 5th x, then plus c. So we have the integral of tangent cube x second to the 5th x dx.